Hello and welcome to the channel. In this video we're going to be taking a journey back to spring 1998, around the time of the release of this IWILL DBD100 motherboard that has been designed for dual slot 1 processors. This board would have been an absolute beast at the time, but this hardware would not have been available to the regular consumer like you or I, as this board is considered a server or workstation motherboard. Specific MSRP is not explicitly listed in any of my search results, but similar high-end dual slot 1 motherboards from that era typically retailed in the $250 to $350 range, approximately 154 to 215 British pounds. This board runs on the Intel 440BX Seattle chipset with an FSP speed of 66 and 100 MHz and support for up to 1GB of SD-RAM, utilising the 4 168-pin UDIMM slots. In-out ports consist of one floppy drive interface, 2 IDE interfaces, one PS2 keyboard, one PS2 mouse port, one parallel, 2 serial and 2 USB 1 ports. For expansion slots we've got 2 16-bit ISA, 4 32-bit PCI and one 3.3 volt AGP slot. The processors I'm going to be using are 2 Intel Pentium II 350MHz CPUs with the S-spec numbers SL356. As you can see printed here on the top of the CPU, 350/512/100/2.0V. These numbers identify that the processor features a 350MHz core frequency, a 512KB level 2 cache, 100MHz bus speed, and operates at 2 volts. The Intel Pentium II SL356 is a desktop processor from the Dosbench core family, released in 1998. Dosbench, I think I said that right. For testing purposes, a 64MB Micron PC133 SD-RAM module should be more than adequate. Right then, let's place this into the test bench and do some testing. After a few attempts at booting and getting no post screen, I've pulled out the AGP S3 Savage4 to replace it with the PCI S3 Verge to see if I could get a post screen. Still getting no results, I resorted to attempting to boot with just a single processor. With that also not producing a post screen, I decided to change processors completely to a 300MHz Pentium II that I used in a previous video and I knew was working. And eventually I also changed the memory module to a 128MB Samsung PC133 RDIMM, as this motherboard is considered a server board and they tend to support registered modules that use a hardware register to buffer, address and command signals between the RAM and the memory controller, increasing stability and capacity for servers, whereas unregistered or unbuffered memory connects directly, offering faster performance for consumer PCs. And eventually all the hard work and messing around paid off, and I eventually got a post screen. That was a glorious sight to see. As I only intended on doing a Dosbench on this board in this video, I'll only be able to test a single processor anyway, so I'm just going to press on with the benchmarks. PC player in 640x480 scores 25.2 frames per second. Zoom in high detail for faster PCs timed 2134 game ticks in 891 real ticks. To calculate Doom's FPS, divide the number of game ticks by the real ticks and multiply by 35. That gives us a result of 83.8 frames per second. Quake in 640x480 scores an impressive 72.8 frames per second. And finally in speed test we're getting the processor benchmark score of 344.57. Testing memory timings are as follows. The 16KB data cache level 1 transfers 1130.57 MB per second. The 512KB data cache level 2 transfers 444.61 MB per second. And the memory throughput is 234.98 MB per second. Sweet, that is a lovely set of results. And so is getting this machine to fully post with 2 processors installed, and the AGP Savage4. But only to discover that sadly on post, it's still only showing that 1 processor has been detected. I do believe that this processor in the second slot is non-functional. I couldn't get a post screen when it was in the first slot, and unfortunately I don't have any other matching P2 processors, but I will do a second Dosbench with the 350MHz Pentium II. PC player in 640x480 scores 26.2 frames per second. That is up 1 frame per second from the previous benchmark. Doom in high detail for faster PCs timed 2134 game ticks in 778 real ticks. And again, to calculate Doom's frames per second, we divide the number of game ticks by the real ticks and multiply by 35. That gives us a result of 96 frames per second. That is an increase of 12.2 frames per second on the previous benchmark. Quake in 640x480 scores a less impressive 53.5 frames per second, which is 19.3 less than the previous benchmark. That is quite a surprising result, as we're using a slightly faster CPU and we're using a graphics card using the AGP bus. Obviously Quake doesn't necessarily rely on the graphics card per se, it's more based on CPU processing power, the speed of the FPU. But still, that gives us a very confusing result. And moving on to the final benchmark, SpeedSys, and we're getting a processor benchmark score of 402.01. Testing memory timing results are as follows. The 16KB data cache level 1 transfers 1335 megabytes per second. The 512KB data cache level 2 transfers 499.25 megabytes per second, and the memory throughput is 228.75. Overall, a really good test for this board. Unfortunately, I was unable to get a post with both processors function, but it'll just add more components to the list of wants. On the second run of the benchmarks, we got mostly improved results over the first time, apart from the Quake results that was surprisingly down from 72.8 frames per second to 53.5, even though that in the second benchmark we used a faster processor and an AGP graphics card, so that does seem to be a little confusing. Also, the memory throughput on SpeedSys was slightly down from 234.98 megabytes per second to 228.75. That could just be that on the second benchmark I tested using 2 memory modules, that may have slightly impacted the memory throughput. Other than those slight drops in performance, all testing went well, and this board is good to be used in a nice dual Pentium build.